Welcome to the Gen AI Daily Briefing for Sunday, August 9th, 2026. The most important story today is probably not a launch, but a slowdown. OpenAI says it has paused internal work around an in-development model called Astra after the system hit what it calls a critical cybersecurity threshold. In plain terms, the company is saying the model became capable enough in offensive cyber tasks that the old safety envelope no longer looked adequate. That matters for two reasons. First, it's another signal that cyber is becoming the first domain where frontier labs are willing to publicly admit capability overhang before release. Second, it suggests the gating function is shifting from broad benchmark scores to concrete operational risk. Can the model chain reconnaissance, exploit selection, and attack execution against hardened targets with enough autonomy to matter? If that framing holds, expect more stage deployment, narrower access controls, and more red team evidence requirements before the next agentic releases. The bigger industry read is that the race is no longer just model quality versus latency and cost. It's model quality versus controllability in high-consequence domains. Next up, Cloudflare launched Kitesurf, a browser built for AI agents rather than humans. This is one of those infrastructure moves that could end up being more important than the headline suggests. Most browser agents today piggyback on full Chromium stacks, which are heavy, brittle, and over-provisioned for machine-driven workflows. Kitesurf is essentially an attempt to make browser execution a cloud primitive for agents. Lower compute overhead, tighter orchestration, and presumably cleaner observability and policy hooks. If it works, that changes the economics of web agents in a meaningful way. A lot of current demos break when you scale from a handful of concurrent sessions to thousands of task attempts because browser runtime cost and reliability dominate the LLM bill. The strategic angle is also classic Cloudflare. Own the edge, own the traffic, then move up the stack into the execution substrate for autonomous software. On the technical side, one of the more interesting science stories comes from DeepMind's WeatherNext, which has surprised weather scientists with strong hurricane prediction performance while using lower resolution weather data. That combination is worth paying attention to. We've seen AI weather systems get good at emulating or surpassing numerical weather prediction on selected tasks. But the practical question has always been whether they can do it with less data movement and less expensive compute. Lower resolution input that still produces strong forecast quality is a real efficiency story, not just a benchmark story. It points to a broader pattern in foundation-style scientific models. Learned priors can recover structure that classical pipelines often pay for with brute force resolution. For engineering leaders, the takeaway is not LLMs everywhere, but that the playbook of compressing expensive simulation with learned surrogates keeps extending into operationally critical domains. Meanwhile, ByteDance is reportedly training a 10 trillion parameter model as it tries to move into the top tier of frontier competition. Parameter count alone is not a product strategy, and at this point, everybody in the field knows that. Still, the report is revealing. It says two things about the market. One, Chinese internet giants are still willing to fund truly massive training efforts despite export control friction and infrastructure constraints. Two, competition is broadening beyond the now familiar OpenAI, Anthropic, Google, Meta quartet. The engineering question is whether this is dense scale for signaling or part of a more serious mixture of experts or hierarchical system that uses giant capacity but only sparse activation at inference. If it's the latter, it's a serious bid. If it's the former, it's expensive theater. Either way, expect more model sovereignty narratives, especially as domestic ecosystems want frontier-grade stacks not fully dependent on U.S. vendors. On the market side, Amazon is facing scrutiny over a planned West Texas data center backed by an on-site power plant that could become one of the largest single sources of climate pollution in the country. This is the AI infrastructure trade-off in very concrete form. Everyone wants more training and inference capacity, but the clean power queue is slow, grid interconnection is slow, and hyperscalers are increasingly willing to buy certainty with gas. That may be rational from a capacity planning perspective, but it is going to collide head-on with corporate climate claims and with local permitting politics. For architects, this becomes a non-trivial supply question. Where your workloads run is increasingly tied to energy availability, not just region latency and accelerator inventory. Over the next year, expect data center siting, power contracts, and transmission bottlenecks to become core AI strategy topics rather than back-office infrastructure details. Worth flagging as an ecosystem move, OpenAI acquired presentation startup NextSlide, with the team now working on ChatGPT. On its face, this is a small tuck-in, but strategically, it fits the larger pattern. The battleground is shifting from generic assistance to artifact creation embedded in workflows. Slides are actually a nasty product problem because they combine planning, visual layout, enterprise-style constraints, and iterative editing. If ChatGPT gets materially better at generating presentation-ready outputs, not just text dumps in a canvas, that strengthens the case for AI as a front-end to knowledge work rather than a sidecar. It also puts more pressure on productivity incumbents, because the winning interface may not be AI inside Office software so much as Office software generated from AI intent. A couple of papers from AR14 are also unusually practical. One, called The Bitter Lesson of Tool Calling, compares native JSON function calling against programmatic tool calling, where the model writes code to invoke and chain tools. The result is intuitive but still important. Code-based orchestration often performs better under realistic task conditions because it handles control flow, retries, branching, and parallelism more naturally than a rigid function schema. This tracks with what many engineering teams have learned the hard way. Function calling is great for bounded API actions. It gets awkward when tasks become stateful and compositional. The caveat is obvious. You trade off safety and interpretability for flexibility unless the execution harness is very well sandboxed. Another paper introduces selective context preference optimization and a benchmark called MIST for teaching models when to trust external context and when to ignore it. This is a big real-world problem disguised as a small alignment problem. Many production failures in RAG systems aren't hallucinations from nowhere. They're obedient errors where the model latches onto the wrong retrieved snippet, stale policy text, or misleading tool output. Training a model to distrust everything just makes it inert. Training it to trust everything makes it gullible. Selective trust is the actual target, and it's surprisingly undermeasured today. And related to agent reliability, a paper called TragDebug looks at long-horizon agent failures by trying to identify the earliest step in a trajectory that causes the eventual miss. That sounds niche, but it's exactly what agent teams need. Once an agent runs stretches across dozens of observations, tool calls, and intermediate plans, postmortems become nearly impossible. If the field wants agent engineering to feel more like software engineering and less like seance, root cause tracing has to improve. Stepping back, the through line today is control. Control over dangerous capabilities, control over browser execution, control over scientific compute efficiency, control over tool orchestration, control over energy supply, and control over where agent failures actually begin. The frontier is still moving on raw capability, but the investable and operational story is increasingly about who can package capability into systems that are governable and economically scalable. What to watch next? Whether OpenAI's Astra pause triggers similar disclosures from rivals. Whether agent browsers become a real infrastructure category or remain a demo layer. And whether power constraints start shaping AI deployment roadmaps as much as model quality does. That's your briefing. We'll see you tomorrow.